Hi everybody. Today we're looking at solving trigonometric equations. So, the first thing to note is that for a trigonometric equation it goes in cycles, so there's infinitely many solutions. So our first solution here is in the first quadrant at x equals 30. There's a second solution at x equals 150. There's another solution over here somewhere. And there's two solutions before 0 that we're showing at negative 210 at negative 30. Sorry, that's not right, is it? That looks like negative 33, and that should be negative 330. There we go. And similarly, there'll be two more solutions over here somewhere. Now, I've highlighted the first sector solutions, the first quadrant solutions in yellow. So that's between 0 and 90 from our unit circle, and that's for 30 degrees, that's going to be 0.5. Now the cast diagram, C-A-S-T, indicates that the next positive solution is in the second quadrant between 90 and 180, so it'll be this solution here. We put the first quadrant angle in here, measure from there, which tells us that if the first quadrant angle is 30, the next one will be 150 or 180, take 30, which is what I've done here. Similarly, if we're looking for the negative solutions, the solutions where x is negative, but the result will be positive, sine x will be positive, put 30 in here and measure clockwise. So it'll be 180 plus 30, and 360 take 30. So 180 plus 30 will be negative 210, because we're going in the negative direction. And if we keep going all the way around, it'll be 360 take 30, which will be 330 degrees. And as stated earlier, we can use this same idea for angles greater than 360 degrees. So here's from 0 to 360. Now we're going from 360 to 720. And the first one, if we go all the way around 360 degrees plus another 30, that'll give us 390. And if we go all the way around plus the extra 150, that'll give us 510. That's what these bits indicate. So let's see if we can figure out all the solutions for sine x equals negative 3 on 2 between 0 and 360. So looking at sine and looking at negative solutions. So the first negative solution for sine is in the third quadrant, and the second solution for sine is in the fourth quadrant, but we don't know the first quadrant solution yet. We know that we're looking for root 3 on 2, and if we use a triangle to help us find out what sine is for root 3 on 2, it would be opposite over hypotenuse, which is sine 60. So the first quadrant positive solution will be 60. Now we're looking for the third quadrant solution, so that would be 180 plus 60, which would be 240. And the fourth quadrant solution, which would be 360 take 60, which will be 300. That's what I've done here. So we know that sine x is negative root 3 on 2 at 240 degrees and 300 degrees. Example 11 complete. Example 12 is similar, remembering that the period for tan is 180 degrees, or one cycle is 180 degrees. We're looking for where tan is positive. So we know tan's going to be positive in the first quadrant because everything's positive in the first quadrant. And tan's also positive in the third quadrant, C-A-S-T, tan positive. We're looking for solutions between 0 and 2 pi, so we're looking for the positive for values of x between 0 and 2 pi, or if we convert back to degrees, that's 0 and 360 degrees. So the first one, are we looking for a positive or a negative solution? Oh, we're looking for a negative solution, so we are looking for these two quadrants. I just found it for Let's read the question correctly. Solve tan x equals -1 on root 3 between 0 and 2 pi. We can find out where the positive solutions are and then use that to find the negative solutions. So 1 on root 3, opposite over adjacent, using our little triangle, that's going to be tan 30. Find the negative solutions. Take 30 away from 180. So 30 is pi on 6. Pi can be changed to 6 pi on 6, which is still pi. 6 pi on 6, take pi on 6, gives us 5 pi on 6. So that's our first solution. The second solution, all the way around the triangle, all the way around the cast diagram would be 2 pi, 360 degrees. And we want to take away 30 degrees. We want to take away pi on 6 degrees. So 2 pi is the same as 12 pi on 6. 12 pi, take pi, will give us 11 pi on 6. And there's our two solutions. 5 pi on 6, our first quadrant solution. 5 pi on 6, our second quadrant solution, and 11 pi on 6, our fourth quadrant solution. Now, our calculator will help us if we're allowed to use it, and this is typically a non-calculator section, but if we had to do it as part of a larger question, we can say sine x equals -√3 divided by 2. Here it is here. Solve for the answer between 0 and 360, and it will give us the two solutions that we found here. If we left this in, actually I should probably do that. Let's, oh, it's still here. Let's put √3 on 2 here. Sine x equals 3 to the power of 0.5 brackets divided by 2. Now that gives us, we wanted negative, didn't we? Oh, we're doing tan, weren't we? What else will we do? We'll do sine. Okay, so there's two solutions, and if we want it in standard mode, oops, not that one. Try again. And if we want it in radians, there's some solutions. That's an awful lot of solutions. Oh, because I've said between 0 and 360 instead of 0 and 2 pi. There we go. Now let's do this for tan. So tan x equals -1 on √3. There's our 5 pi on 6 and our 11 pi on 6. Okay, let's have a look at example 13. So cos x equals 0.2 and it has solutions of 78.5. Determine all the solutions between -180 and 180. So -180 would be from here to here, 180 would be from there to there. We know that the first quadrant solution, because that's in the first quadrant, is 78.5. We want to look for any other solutions. Now, cos is positive, or all stations to claim on C-A-S-T. C-A-S-T. So cos is positive in the fourth quadrant and the first quadrant. Now we know the first quadrant solution 78.5. If we substitute in the angle here and work clockwise, we can find the negative solution for x. That's going to be -78.5. Nice easy one, that one. Example 14. Sine of 36.9 equals 0.6. Determine all the solutions for 5 sine x equals 3 between 0 and 720 degrees. Should probably put that degrees in there. So 5 sine x equals 3. Sine x equals 3 on 5, which is 0.6, which is how we bring this solution into play. 36.9 is in the first quadrant. And we're looking for positive values of sine x, which is in the first quadrant and the second quadrant. So we can find the second quadrant solution by subtracting the first quadrant solution from 180, which gives us 143.1. We're also looking for solutions between 360 and 720. So to find those, we can add 360 degrees to our first and second quadrant solutions, which is what I've done here. And we get 396.9 and 503.1. So we have 4 solutions between 0 and 720 degrees. That one, that one, that one, and that one. Example 15, there's a few examples for this one. Given tan 1.11 equals 2, solve sine x equals negative 2 cos x between negative pi and pi. So we want our solutions in radians, because it's been given to us in radians. But the connection between this equation and this equation isn't immediately obvious. What we're going to do is we're going to divide both sides by cos x. Now, if we divide both solutions by cos x, there is one problem with that, and it's never brought up by Sadler, and I don't think it's part of the course, but I'll raise it anyway. If you divide by cos x, the values where cos x equals 0 are going to be undefined. We should probably going to be taken into account by tan x this time, so that's not such a problem. It is a problem in other solutions that Sadler does, though. So, dividing this side by cos x will give you negative 2. Dividing this side by cos x will give you tan x. Sin x divided by cos x is tan x, proven earlier in the exercises. So that gives us tan x equals negative 2, which brings us back to this solution here. We know that tan x is 2 at tan 1.11. First quadrant solutions are going to be between 0 and half of 3.14, which 1.11 definitely is. So we can see that this is the first quadrant solution. And we're looking for the negative solutions for tan x. So that's going to be in this quadrant here and this quadrant here. So that's going to be pi take 1.11, and on this side it'll just be 1.11, and there are those two solutions there. How many more have we got? No, just one more. It's a long one though. Example 16, where cos of 2x equals 0.5 between 0 and 2 pi. So the solutions we have at the end of the day must be between 0 and 2 pi. But first we should find out if we ignore the 2x for now, what solution for cos x is 0.5. So cos adjacent over hypotenuse, that gives us a half. So we know that it must be pi on 3. 180 divided by 3 is 60. And we have positive solutions for, because this has a positive solution, positive solutions for cos in the first and fourth quadrant. Yep. So if we ignore the 2x for now, we know that the solutions are going to be pi on 3, 5 pi on 3, and rotations of that. So the problem that we have though is this is so far we've only got it for x, not for 2x. So if 2x equals pi on 3, x is going to be pi on 6. So if we change our first two solutions now, our first solution becomes pi on 6. Our second solution for 5 pi on 6, for 5 pi on 3, 2x equals 5 pi on 3, divide both sides by 2, we get x equals 5 pi on 6. So solution 1, pi on 6, solution 2, 5 pi on 6. That only gets us as far as 180 degrees. We have to go all the way through to 2 pi or 360 degrees, so we're going to consider the next cycle now. Now what this is trying to say is we're going to add on 2 pi. So to get us to the next revolution solutions. So pi on 3 plus 2 pi on 3 gives us 7 pi on 3. 5 pi on 3 plus another 2 pi on 3 gives us 11 pi on 3. Now if we again do our conversion from x to 2x, 2x is equal to 7 pi on 3, x will be equal to 7 pi on 6. 2x is equal to 11 pi on 6, x is equal to 11 pi on 6. that gives us our next two solutions. This is getting very close to 2 pi now. In fact, if we go to the next cycle, that will go over 2 pi, which is the bounds that we were originally given. So we know that these are the only 4 solutions. This is a little bit confusing at first, but it is quite simple once you get your head around it. Last one, example 17. Solve 2 sine squared x take 3 sine x take 2, remembering that 2 sine squared x is actually sine x 2 times sine x times sine x. Now to solve this, I'm just going to let y equal sine x into a substitution. So we get left with, wherever we've got sine x, I'm now going to put y. 2 sine squared x becomes 2y squared. 3 sine x becomes 3y. And 2 stays as 2. That's a quadratic. Solve the quadratic. Get left with y equals negative a half, y equals 2. Resubstitute sine x for y. Sine x equals negative a half. There it is there. Sine x equals 2. Sine x can't equal 2. That's not a solution. Sine x equals negative a half. We know from earlier that that's sine x is a half, would be opposite over hypotenuse, sine 30, which is pi on 6. I'm guessing that I didn't actually state here that this is between 0 and 2 pi. Looking at the solution. Now, we now have to look at where sine is going to be positive or negative. Sine x equals negative a half, so that'll be the third and fourth quadrants. So that'll be pi plus pi on 6, which will give us 7 pi on 6. 2 pi minus pi on 6, which is 12 pi on 6, take pi on 6, which is 11 pi on 6. Oops, I'm guessing that that's to 4 pi because we've got an extra 2 solutions here. So if we keep going around another revolution, that'll be 3 pi take pi on 6, which is 19 pi on 6, and 4 pi minus pi on 6, which is 23 pi on 6. Now, if all that makes sense, exercise 8D should be quite simple. If not, it does build you up quite slowly. So work your way through the exercise and ask any questions if you have to. Thanks, everyone.